Welcome to clickmyproject.com. Let's discuss the project about healthcare improvement, comparative analysis of two CAD systems in mammochromic screening. In our first work, a comparative analysis is performed among different techniques applied to identify microcalcifications organized in a cluster structure. Two different classification techniques are considered and compared: the artificial neural network and the support vector machine. Two systems have been employed and compared for automatic detection of microcalcification clusters in mammochromic images. The implemented techniques adopt a three-layer artificial neural network and an SVM with KNN classifier respectively. The major difference between the adapted classifier is in the error optimization. In artificial neural network, the aim of learning is to obtain a set of weighted values which minimize the training error, while in SVM, the training error is set to minimum while training adjusts the capacity of the machine. This is the flow of our process. First we load our input image and then we are applying pre-processing step. In the pre-processing step, noise is removing with the help of median filter. Median filter is a non-linear digital filtering technique often used to remove noises. Such noise reduction is a typical pre-processing step to improve the results of later processing. Median filtering is widely used in digital image processing. We have seen the smoothing filters reduce noise. However, the underlying assumptions is that the neighboring pixels represents additional samples of the same values as the reference pixels, that is, they represent the same features at edges. This is clearly not true, and blurring of features results. We have used convolution techniques to implement weighting corners as the neighborhood functions, which represents a linear process. There are also non-linear neighborhood operations that can be performed for the purpose of noise reduction that can do a better job of preserving edges than simple smoothing filters. Then we will go for segmentation. Segmentation refers to the process of partitioning a digital image into multiple segments or regions. The goal of segmentation is to simplify the representation of an image into something that is more meaningful and easier to analyze. Here we are applying segmentation to segment the microcalcifications pixels. Then we will go for feature extraction. For feature extraction, here we are applying GLCM to extract features. A gray level co-occurrence matrix contains information about the position of pixels having similar gray level values. There are totally 12 features are extracted: contrast, correlation, cluster prominence, cluster shade, dissimilarity, energy, entropy, homogeneity, maximum probability, sum of squares, auto, and inverse difference moment. Then extracted features are passed through three types of classifiers: artificial neural network, SVM, and KNN. ANN works as ANN or computationally models inspired by animal central nervous system that are capable of machine learning and pattern recognition. They are usually presented as systems of interconnected neurons that can compute values from inputs by feeding information throughout the information. Likewise, SVM maps input vector to a higher dimensional vector space where an optimal hyperplane is constructed. Among the many hyperplanes available, there is only one hyperplane that maximizes the distance between itself and the nearest data vectors of each category. This hyperplane, which maximizes the margin, is called the optimal separating hyperplane, and the margin is defined as the sum of distance of the hyperplane to the closest training vectors of each category. Then it will recognize belonging the hyperplane. Then KNN works as where both distance metric and number of neighbors can be altered. The object classifies new observation using the periodic predict method. The object contains the data used for training, so can compute resubstitutioning predictions. Then it will predict the results. Now let us see the execution of the process. First we select main.m file and click run file. This is a guide window designed for our process. First we select our test image. This is our data set. There are totally 30 images is available in our data set. The data set is from, we are collecting from Maya's database. We can select any one of the image. Now I select this image. Input image is successfully loaded here, and then we apply noise removal technique to removing the noises in our data set. Here we are applying median filter to remove the noises. Resultant is displayed here. Noise is nothing but some unwanted things. This contaminants on image. Here with the help of median filter we will remove that, and then we will go for our contrast. Use for main pixels we are extracting here with the pre-processing step. We are applying top hat technique to having this results. Then we will go for the segmentation. The abnormal, if any abnormal pixel is there, means it will be segmented, and then we will go for our feature extraction step. In the feature extraction, both test and train features are also displayed here. There are totally 30 images in our dataset. Each and every images are having pre-processed and segmentation done, and feature extraction is done. Extracted features are arranged here. Here we are extracting the features with the help of GLCM technique, gray level co-occurrence matrix. These are the values like contrast, correlation, energy, entropy. These types of values is displayed here. Then we will go for our classification. In the classification we are applying several types of classification. First we will apply SVM classification. Then SVM returns the given image is abnormal one. Then it works as 83% accuracy. Then we will apply neural network classifier. It will display given images normal one, and this is worked with 86% accuracy. Then we will go for our Bayesian. It will work on 70% accuracy. It will return as normal, and we will go for ANFIS classifier. ANFIS is worked, and it will give 100% accuracy. And at last KNN classifier we will do. That is also gives 100% accuracy. Then finally we will calculate the performance of the each and every classifier: SVM, neural network, Bayesian, ANFIS and KNN. ANFIS and KNN returns the best performance. Thank you.